So good morning, all of you. Sorry, good evening, all of you. My voice is audible. Is my voice is clear? Hello?
Yes, sir.
Yeah, right. Thank you.
Yes, yes,
So,
yes, sir.
right.
Yes, you are audible.
So now, so last day I told you the data is represented in the form of JSON format. The JSON is text based and it is more convenient for developer. Okay, it is like a top level one. So at the low level, all the data is stored in the form of binary. Okay, it is a format of JSON. Okay, so here, right here I provide the link. And last day I'm unable to upload the document due to some technical issue. Okay, today I will share this document to all of you. Okay, now, so here, suppose I want to represent some data on the screen on the UI. Okay, like this. Suppose the name of the person and the course is selected by that student. Okay, right. I mean that person, right? I want to represent the data like this. Okay, so here, see, always think in terms of your usage. Okay, I need data to be presented in this way. That's all. Okay, right. Name and courses. Maybe some other properties also. Okay, right now to simplify this, I have chosen this one. Okay, so here, so in a training organization, okay, we have a page to display where we are going to display the student names and courses which are selected by that student. Okay, now it is like this. Now, if you want to achieve the same output by using a traditional database like a relational database to model this or to present this data, I mean to achieve this data or to get this output, first you need to store that data in the backend database. Okay, so here if it is in a RDB mesh, I mean it is a relational database, then we need to create three tables first. So first of all, you need to store student data in one table, okay, with some properties like ID and name. Okay, right. The courses, you need to store courses data with the property course ID and course name, student ID and student name, course ID and course name. And let us create one more table with the name student courses. Okay, there is a many to many relationship between the student and courses. It is a many to many relationship. Okay, what is the meaning of that? A student can enroll in multiple courses. Okay, so similarly, a given course can be chosen by multiple students also. It is a many to many relationship. Okay, so that in this table that links the student and courses as follows. See this? So I created a student table with student ID and student name. Okay, right. See that? I created student table with the student ID and student name. So here there are the four students and their IDs are 1, 2, 3 and 4. Their names are John, Miller and Swaminathan Rajaram. Now the courses is another table where course ID and course name. So the course names are, see the course IDs are 1 to 11 and these are the names. Now I want to store students and the the courses which are selected by that student. So student ID 1, okay. The student 1 selected course 1. It means student 1 means John, selected 1 means selected the course ID, selected course ID is 1, so that meant. So 1, 1. Now the same student selected one more course also. So student ID 1 and it is 4. 4 means .NET. Okay. Now the student ID 1 selected one more course 6. It is SQL Server. So one student, okay, one student selected three courses, 1, 4 and 6 courses. Now in the same way, second student selected some courses, 2, 3, 7. Third student selected 5, 6, 10. Okay, the fourth student selected four courses, 5, 9, 8 and 11. So in this way, you need to create three tables to store this above data. This one, okay, in the relational database. So on our application side, okay, it is backend. But whenever you want to display this data front end through an object, okay, here you need to collect the data from these three tables, and it need to be encapsulated through one object. Okay, because see, always transmitting the data from one layer to another layer. Okay, if it happens through one encapsulated business object, BO, business object. Okay, from one layer to another layer. Okay, if it is by one object, it is very easy for us. Suppose if you want to transmit the data in terms of multiple objects, it becomes highly complex. Okay, and even transmission also little bit unsecured. And at any instance of time, if it is interrupted, resuming that transmission and finding the data which is skipped or which is not transmitted, which is missed. Okay, it is again a biggest lengthy process. Okay, complex process. So here see, to encapsulate all this data together as one unit, okay, through a oops concept, you need to create a class. Okay, class student courses. Okay, some id, name. Id means student id. Okay, name means student name, and the courses selected by that student are as a string array. Okay, so this is the class. This is the class which is representing the data came from three tables. Okay, in the backend, the data is in three tables, but in the application model, okay, in the application logic, that three tables data is the data is collected from the three tables, and it is made as one through this class. Okay, so the conversion of data, taking the data from three tables and making it as one class object, is a complex process. To make this job simple, the ORM frameworks are came. Okay, that is the main thing. So what is my aim here? The backend data is RDBMS. Okay, right? I mean relational format tables, but the front end processing elements are objects. The front end processing elements are objects. So you need to take the data from tables and they need to be turned as objects. And that too, take the data from multiple tables and they need to be made as one. Then only you can represent the data, okay, very easily, because all the data is, this data is related. It is not unrelated. Name, student ID, whose name it is, this student ID's name. Okay, whose ID it is, this student's name, this student's ID. Now, these courses selected by this student. So these three are related. But in the application, inside the class, these three are related. But in the same way how they are inside the class, in the same way you are storing in the database. In the same way how inside the class, in the same way you are storing in the backend database. No, here in the class they are three related as one unit, but in the backend, are you storing that data in the same way? No, this is the mismatch happening between the processing logic and backend storing logic or the storing design. Okay, so see this. So here, see this. In the real world, in our application layer, we may use object-oriented programming concepts like inheritance and polymorphism between the classes, which makes it even more difficult and painful exercise to map our application layer objects to database tables and rows. That is the key point. You are creating an object in the front end, in the front end logic, but that object gets the data from backend tables where they are more. Okay, so you need to collect the data from multiple tables, and they need to be mapped to the front end object properties. Okay, so it is a little bit a complex process. It is not that much easy. So the point that okay, see this. There is a lot of misalignment between the application classes and database tables. You are using classes in the front end programming language. It may be Java, or it may be C# or any object oriented language. But in the back end, you are storing the data in the form of tables. Classes and tables are not matching. Okay, the class encapsulates all. Okay, whereas the table, it is normalized so that the data is divided. So a class can encapsulate multiple tables also. This is the best example, because this class going to store student data, ID data, okay, name, and courses also. It is one class, but one class getting the data from three tables. Okay. So to perform, to sync between this front end class and back end tables, okay, it is not that much easy. Okay, right. So to fill this gap and misalignment, you may write our own custom mapping layer called as ORM, Object Relation Mappers, like Entity Framework or the Spring Boot. Okay, right, in such a way. As a software is want a database that is easy to use without our application code. This is the main key point for MongoDB. Okay, so without this mapping, I mean to simplify the front end usage model and back end storing model, both should be same. Okay, or at least very close. Okay, how you are storing the data and how you are using the data. Okay, right. Right. So how you are storing the data and how you are using the data. These two should be sync or similar. Then what happens? It is very easy for application developer to handle. Right. That is. So that's why the non-relational database and MongoDB. Right. Now here, see this. Some data may be stored in a non-relational database like MongoDB. In Mongo, we do not have tables and rows. Instead, we have collections and documents. Okay. See here, suppose I want to store the data of the above element. I can store like this. I can create objects. See this. See, it is 3 objects. Okay, or 4 objects or 5 objects. Just assume. Okay, opening curly brace and closing curly brace, key and value, right? Name and courses, right? Now, now this one object is called as doc or document. Okay, so the it is nothing but simply say row. Okay, this one row. Now the collection of docs. See the set of docs is called as collection. Okay, now this collection is called as table, and each document is called as one row. And here this ID, name, and courses are called as fields. Okay, right. Now next, the student courses collection. Okay, now you can think of collection in MongoDB as a table, in a relational database as a relation database, and document as a table row. Now, so in this example, we have one collection. Okay, the name of the collection is student courses. In this collection, we have 3 documents. Now, just like how a table is a container for rows, a collection is a container for documents. Okay, in the document that physically stores the data. That is the key point. Now, the data is in JSON format, so documents also called as JSON documents. Okay, if you see now, here the point is MongoDB stores data on the disk in JSON format. Okay, right. Now, the same students and courses data that we have across 3 tables in a relational database can be stored in a single collection in Mongo. That is, you no need to store that data in 3 tables. In Mongo, you can collectively store that data as a single element, which is actually requires 3 tables in relational. Okay, even though you stored that data, okay, in the multiple tables, but when it comes to the application layer, again you need to convert them into as a single unit, right? So that even though you stored in the form of relational, but still development point of view, you need to get that data from the backend, from the tables, and they need to be turned as one single object, right? I mean, they need to be united, right? Or they need to be merged, right? That is. Now, see, for an application, this data is very easy to work with it. No complex joins and mapping layers are required. That is the key point. Our application code will be much cleaner and simpler and easier to maintain because student courses, okay, when you are explaining about your code, okay, you are working on 3 tables, okay, you are working on, okay, you need all the data together as one, right? So why? Because the 3 tables collectively represents one particular student's data. Okay, I mean the students' data together, student and courses data together, right? So that, see that relationships between the documents in MongoDB. So see this. So see this here. Is it possible to define the relationship between the documents in the MongoDB? Okay, in a non-relational database? Well, okay, yes, you can do it. We can define the relationship between the documents in MongoDB, but these are usually kept to an absolute minimum. Okay, it means maximum you need to try to minimize that relationships. Last day I told you, if you are using relationships means better to go for relational database. That is, in most cases, we embed the JSON documents inside the another document. This is the most important point. Wherever the relation is required, okay, better to embed the document in another document. Clear? That is. The obvious benefit of this approach is we have all the data we need in one place. There is no need to traverse multiple related documents. That is the point. Here is the important bit. We can define relationships or references in MongoDB. Okay. We can even completely normalize the schema in MongoDB also, just like a normal relational database. We have facility. But the point is, but the question is, if you want normalize and use a non-relational database like a relational database, why the use of non-relational database? Okay, use or go for relational database. Okay, there is no second thought about it. If your priority is normalization, go with relational database. Okay, that is. Now, so when to use SQL database and over the non-relational database? See, relational database are still best choice if the data is predictable in terms of structure, size, and frequency of access. Also, if the relationships between the entities are important, again, the relational databases are the best choice. That is very important because the structure, if you want to create a table, you must have an idea about structure, clear cut idea, because the number data type, okay, so string data type, right, varchar, like that, depending upon the database you are using, right, string, date, right, so binary, right, so not binary, sorry, a boolean, okay, right. So in such a way, different types of data, floating point, non-floating point, right, depending upon the database, the data types may change. In Oracle, some database, some types of data types are there. In SQL Server, some types of data types are there, right? So normalization in a relational database reduces the size of the data on disk. See, because you have, see, relational database, we have so many extraordinary benefits. What among them is it reduces the size of data, because due to normalization, you can avoid duplication of data. But in MongoDB, as you are embedding data, embedding a document within the document, embedding an object within the object, sometimes if you are not handled it properly, sometimes it leads to duplication of data also. Okay, no doubt about it. So size on the, see the size of the data on disk by limiting duplicate data and anomalies. This is the important point. In a non-relational database, documents are embedded within the documents, which helps keep data that will be accessed together in the same place. But if this is not right for your needs, use relational database. For example, if you have a large data set with complex structure and relationships, embedding might not create the clear enough relationships. But wherever you want the exact relationships, accurate relationships, okay, then go with relational. That is. So finally, relational databases have been around for very long time, which means there is a wide support available from tools to integration with data and from other systems also. Because for so many years, from almost 40 to 50 years, okay, the relational databases are under development, so that every company, every vendor develops all the tools with respect to the relational database structure. Okay, so I mean, there is a support. Okay, there is a wide variety of tools. Okay, number of tools are more to support the structure. Okay, right. So yeah, right. Next, if you want a flexible schema, Okay, flexible schema means, see, once you created a structure for table, okay, it is not that much easy to change according to your data, right? So it means data and its structure both are like synonyms in this MongoDB. Okay, there is no difference between structure and its data in some cases. Okay, and it means you can use in such a way. Okay, if you are using data, if you are storing data means you are storing its structure also, right? We'll see some examples in the next coming sessions one by one. Okay,
So how, sir?
right. See, if you want flexible schema for data in terms of shape or size, or if it needs to open to the change in the future, then a non-relational database is the best answer. Okay. Next, non-relational database have been designed from the ground up for the cloud. That is, this is also very important point. Okay, it means they are they are designed for to make them to make them more suitable for cloud environment. That is, so which makes them naturally good for horizontal scaling. Okay, I will explain this vertical scaling and horizontal scaling, where lots of smaller servers can be spun up. Spun up means group. Okay, to handle the increased load. That is. So then what is NoSQL stands for? Okay, see this. NoSQL means there is no, okay, SQL. Okay, that is not true actually. See, the term NoSQL stands for not only SQL, that is, and it means a non-relational database is a non-tabular database and stores data differently than relational tables. That's the key point. So, next. For example, in a relational database like SQL Server or Oracle, data is stored in the tables, whereas in a non-relational database like MongoDB, data is stored in JSON documents. So the types of relational databases. Okay, there are different types of non-relational databases. These are all the different types of non-relational databases: document-based, key-value-based, wide column store-based, and graph-based. Okay, different. So the MongoDB comes under document database. Okay, we have different other databases. So suppose if you have uh, idea about data structures, okay, in the data structures, the advanced topics are there: B trees, B plus trees, okay, graphs are there. Okay, so when you have, yeah, when you have idea about that B trees and B plus trees and graphs, okay, then you are able to understand these structures. Okay, see how the data is stored by the database in the backend. Okay, at the low level, hierarchical structure is there. Okay, there are so many. Right, document base. See this first one. As the name implies, data is stored in documents. For example, JSON documents. Okay, the examples of document base are MongoDB and CouchDB. Next, key and value databases. It stores data as a collection of key and value pairs in which the key is used as a unique identifier. This is very important. See, that key is unique. Both keys and values can be anything ranging from simple objects to complex objects. Complex objects means any type of data, like that primitive data to complex object. It is a collection, right? Again. So, example, this one. Now, so DynamoDB and Redis. Next, wide column store. It is similar to relational database in the sense it stores the data in rows and columns. However, the columns are dynamic, means they are not fixed, and each row does not have the same number of columns. But in our RDBMS, okay, every row comes up with equal number of cells. I mean, equal number of columns. Suppose if you create a student table with student ID, name, okay, course with 3 fields, then every row contains the 3 fields, whether they may be with data or not completely, right? But whereas here, the number of columns may change from row to row. Okay, so the examples are HBase and Cassandra. Okay, right. Next, graph database. It is used to store and navigate the relationships. So this is little bit, sometimes it is very useful also, graphs. Okay, if you know the strength of graphs, okay, it is very effective sometimes. So there is no limit to the kind of number of relationships heavily used in fraud detection and social networking, because connectivity. See, it is like a connectivity, navigation. Okay, for that navigation, see, navigation means relation. Okay, so one element is connected with so many elements. Okay, in different ways. Okay, and it can see how it is connected, how you can identify. Okay, the properties, right? Suppose if you see the groups in the Facebook, okay, the data, how one element data, okay, one element is connected with how many, okay, how you are going to identify by using these graphs. So heavily used in social networking. It is easy to create relationships between data entities and quickly query these relationships. For example, you can find out friends of friends, okay, of a particular person. Okay, examples: dgraph and orient db. See, for example, whenever you created one account in FB or somewhere, okay, after some time, once 1 or 2 days is over, every day they show some suggestions to you. These people may know about you. Okay, see, you never given any such type of data. Okay, you never made available of that the data, okay, to that FB, but they identifies that persons. Somehow they are connected, no doubt. Okay, even sometimes the other people, may saw, I mean, may search for you. They are also comes in the suggestion list automatically. So it means somehow they are related. Okay, somehow, right? That is so easy to use a data model in a document base like MongoDB. We do not have tables and rows. Instead, we have collections and documents. The data that we typically store across many relational database tables that can be stored in a single collection, right? See this one. See the flex. This is the benefit of Mongo. Next, flexible schema. Flexible schema means yeah, yes, exactly. Now the flexible schema means JSON documents that are actually store data have a flexible schema. Flexible means changeable, right? Which means it is perfectly okay and normal for two documents to have different fields. See, for example, I have two documents here. Okay, ID, name, okay, and graduated. Here ID, name, and gender. See, these two are different, but it is okay. You can handle it very easily. Whereas in case of tables, it is not possible. If you observe here, it is Boolean type, whereas here it is string type. So even though you change the type, okay, it accepts, no issues. That is the key point. Whereas in case of relational database, it is not possible. So it adjusts the schema according to the content. That is the key point. That's why it is called flexible schema. Okay. So both the documents have ID and name fields. In the first document, we have graduated Boolean field, whereas in the second document, instead of graduated, we have a string gender field. So the point is, document schema in MongoDB is dynamic and self-describing. Okay, every document we save in Mongo can be as a flat and simple or as complex as our application requires. That is okay. It means how your application wants. In the same way, you can store. That's the key point, right? So now it supports the MongoDB supports the query language. Okay, using that query language, you can access the MongoDB data directly. Okay, that query language is called as MQL, MongoDB query language. Is based on JavaScript and very easy to learn because JSON format, everything, object dot method name, right? So when querying data, you have a wide range of options, operators, and expressions and filters. Data is very easy to query and you rarely need joins or transactions. The MongoDB MQL is a fully featured powerful language that allows you to query deep into the documents and even use the aggregation framework to perform complex analytics with just a few lines of code. That is, indexing is also supported, which means documents can be retrieved very quickly. That is so. The next one is easy horizontal scaling. So here, what is that horizontal scaling? Scaling means extending, increasing. So most SQL databases allow only vertical scaling, which is also commonly called as scaling up. Okay, vertical scaling involves adding more resources like memory and storage. It means increase the memory. Okay, increase the storage capacity, right? To the existing database server. It means it is just like suppose you are you are assume that you are a weightlifter. Okay, now you are holding right now 10 kgs weight. Okay, so now I added 10 more kgs. Next, I added 10 more kgs. I added 10 more kgs. So that you are the only person enjoying all the pressure. That is the point. Okay, right? You are holding the total entire weight. Now, here, see, see this here. Database vertical scaling as an upper limit beyond which you can add, which you cannot add, just add more CPU and memory, etc. It means some limitations are there. It is not possible to add more. Suppose if your system is there, very simple, your laptop is there. Okay, depending upon the motherboard, okay, yeah, the maximum RAM the maximum RAM accepted by your laptop is limited, right? Wrong? It depends upon the motherboard model, right? So it may be 80, it may be 8 GB, or it may be 12, or maybe 16, like that only, right? After certain limit, it is not possible to add more RAM, right? So that is called limitation. So there is also downtime is involved. That is also very, very important point. Okay. So when you are productivity point of and performance point of view, downtime is very, very important. So you have to shut the database server down to add more hardware, because hardware changes causes sometimes more damage. So they should be done properly. That is. So when you are trying to when you want to when you want to make the changes in the hardware, the system need to be down. That is the important point. Because while running, you cannot add more. You cannot make the modifications in the hardware. That is. Now horizontal scaling. MongoDB, on the other hand, supports horizontal scaling, which is also commonly called as scale out. In horizontal scaling, data is partitioned and distributed across the many servers. So, in simple terms, scaling horizontally means adding more servers already in the existing pool of servers. Suppose you are handling 10 kgs. Now you need to handle 10 more kgs, but that is handled by some other who is who is connected with you. Okay, that is. So so that what happens? You are already with your own strength. Now for the next 10 kgs, you are not using your strength. Okay, that is by some other. So that what happens? You are with some load and your performance is at optimum position. You are not enjoying the too much pressure. That is handled by some other. But these two are connected. Okay, load balancing. Right. So this means adding more servers to the already existing pool of servers. This means you are not limited to the capacity of a single server. There is no need to turn off the existing servers to add new servers to the pool. So there is no downtime as well. That is. So these are the brief. See, I want to give theory also. Why? Because you need see at the end I am going to show you how to handle the data by using MQL and by using Node Express. Okay, right. The operations, the CRUD operations by using Node Express Web API and MQL, and we are going to show you the installation of MongoDB locally and Compass, and if possible, I will show on cloud also. Okay, right, right. So MongoDB is a multi-cloud document database service. In short, it is a document-oriented database. Now I added a new word called here, cloud. That is multi-cloud. Yeah, I will explain. Just first of all, I have very limited time. Okay, I want to go with all the things step by step, because first of all I need to complete. I want to show one example programmatically. Okay, that is so that once it is completed, I will explain with some scenarios. Okay, right. So to easily get started with MongoDB, you need to download MongoDB server, and you need to use the MongoDB Atlas, which is a fully Mongo managed cloud database on AWS and Azure and GCP. So here this is one important point, cloud database, but at the same time it is like a pay. It is a sometimes it could be it need to be paid, but you can get some free account, okay, with some free space. Okay, so you can use it, or you can install it locally. That is also. So in a web server, is MongoDB. So tomorrow I will show you the total installation procedure and all. And you need to provide your details. Okay, if you have a Google account, it is okay, right? Next, you can get a free account. You can register with a free account. You can get some 500 MB free cloud account. You can handle it. Now, so and it is connected to some local server, maybe Bombay or somewhere. Okay, I mean they provides they use the cloud which is located nearest to you. Okay, mostly for your geography, it may be Bombay or it may be some other. Okay, yeah. So now, but once that account is created, how to connect? Suppose if you have SQL server, then you need a client software. Okay, if Oracle is there, you need a client software. Sometimes the clients are CLI based, okay, or sometimes GUI based, or both also. Okay, because sometimes the CLI is very fast. Okay, GUIs are little bit slow. Okay, because they need to load, they occupies more space, and menu based options, but they are developed. They are very easy to use. So here there are three ways to connect with MongoDB. One is Mongo shell, second one is Mongo Compass, and a custom application. Means by using any programming language, a backend server-side programming especially, you you can connect with that backend cloud or local server, whatever it is. Okay, so see this one. So MongoDB shell. Okay, shell commands. They are called as shell commands. Means the MQL. Okay. Next, MongoDB Compass, GUI based one. This is your program. Okay, it could be Node Express, or it could be a Python, or it could be a Java, or it could be a .NET, anything. See this, MongoDB shell. It is an interactive JavaScript interface for querying and modifying the database data. You can also use it to perform administrative operations like creating database and collections, etc. Next, MongoDB Compass. MongoDB Compass is a GUI for querying, visualizing, and modifying the database data. Behind the scenes, both the shell and Compass uses the same commands to the database server. Why? Because GUI is nothing but a menu-based or a developer-friendly interface. Ultimately, everything need to be done through the commands only, right? So that's why still, from the so many years, every software maintaining their CLI. See that even though still you have Windows 11, but still command prompt is there. The Windows not yet removed the command prompt, right? So SQL Server, we have command prompt. Okay, MySQL, we have command prompt. Oracle, we have command prompt. So for everything, command prompts are mandatory because they execute very fast, and those applications, those tasks which through GUI, which may take more time, they are they are performed very easily through command line. In simple say, uh, in a very less time. Okay, right. So that's why for everything, suppose if you want to create a project, okay, in Angular CLI, okay, if you want to create a project, okay, .NET CLI, right, in such a way, for every environment, okay, for every project management, they provided commands, CLI commands. It may be a database or it may be operating system, anything, right? But the only thing is you need to remember that commands and that syntaxes and options and all. And the order, that syntax is also very important. But once you are familiar with that one, that 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 one becomes more comfortable to you than GUI. Okay, performance point of view. So yeah, see, I will explain about that one. Okay, I already told you. When I am going with step by step, I will show you. Okay, everything. So behind the scenes, see this. Now, or you can use your own custom application by using a .NET or Java or PHP or Node Express or Python, right? So, but the point is, you need some middleware or some driver or some other. Okay, that is. So here, see, see, by using this, you can register and you can get your you can get your free account. Okay, but it is purely online. It is purely online. Okay, whereas one more important, and I mean this cloud comes up with some free account. Okay, which is with limited space and with limited features. You can use it for your practice purposes, no issues. And so to access that remote cloud, the front end, sorry, the front end, the front end client software is very important for us. So the two main softwares, one is Compass and one is the Shell. Okay, these two. Now, this is so the MongoDB community server. You can download it locally. See this one. So 8.0.5 Windows platform MSI. If you click on download, okay, what happens? It is installed local, right? It means you can work with your local projects, right? So next, while it is installing, okay, suppose you can download it and you can start installation. Tomorrow I will show you. While installing, it comes up with Compass installation also automatically. So that what happens? See, by using this, you can connect to local server and you can connect to remote server also. That is okay. So that remote can be okay. The free account which is provided by MongoDB, or sometimes see, these are the features. Azure Cosmos DB for MongoDB. Okay. So it may be on some other cloud. It is Azure cloud. See this. So in such a way, on GCP and on GCP or AWS, okay, on or it belongs to maybe your free account also, which is provided by the MongoDB. Okay, so anything you can use. So by using this front end, this MongoDB Compass through GUI, see this add new connection. That connection requires URL. That URL can be a local MongoDB server URL, or it could be a remote cloud-based MongoDB URL. Okay, that is. So tomorrow on a separate system, I'm going to show you how to create that account, free account, and after that, for our practice purpose, okay, I'm going to install MongoDB locally, okay, with MongoDB Compass and this Mongo shell also, and we will create some database, and we'll do some examples, MongoDB shell commands, and after that, we'll write Node Express code by using a JavaScript, okay, the backend web API, right, which can be consumed with the front end React or maybe Angular, whatever it is. So we are going to write that backend web API with see here. See this MongoDB client wrapper for Mongoose. It's Mongo client. So by using the JavaScript with Express and the npm libraries, okay, we are going to write code which manages the backend MongoDB. Okay, so up to now we are planning in such a way. Okay, later we'll see what are the other examples we can within that given period of time. Okay, right. Okay, right. So I will share this document on Google Classroom. Okay, please check it after around 20 to 30 minutes so that you can get this document on the Google Classroom. Okay, right. Yeah, just a minute. You can get that. This is the classroom link.
So in this classroom link, where I can get the access to the videos.
Yeah. This is the classroom link. Okay.
Yes, sir. I log in classroom link only.
Hmm.
Where I need to access the videos.
I will check and update you because I'm not. I will contact the I will connect with concerned person. Okay, I will update you because they are available. Okay, just after the completion of this class, I will update this document. Last day, I am unable to update due to some technical issue. Okay, so today I will update this document. Okay, so the videos also they are available on that link. Okay, I need to uh, check with concerned person. Okay, right. So right. Okay. Thank you. That's all for today. Tomorrow, I'm going to show you the installations and we are going to start working with MongoDB step by step. See the manual Mongo client and one particular programming language. Okay. So present right now, it is a Node Express and in the next coming other sessions, see uh, with which example with which language we may proceed. Okay. First one is Node and this Mongo client, and we'll see the creation and export and imports. And suppose you have any other data, okay, large data sets are there, then how to get them into the Mongo. Okay, so let us see. Suppose big basket database is there. So can you get that data into this Mongo directly? Okay, suppose 30, 40 thousands of values are there, okay, objects are there, right? How? Because products, okay. So big basket is a collection of products. So how to encapsulate all that? Okay.
Sir, can I get a little bit difference between server and cloud? Like in a server, we are like running the application. I don't have the idea about cloud.
See, tomorrow I will give the idea about the clouds. Okay.
A
Right.
small difference,
I
like server and I am getting confused.
see the server is independent software. Cloud is different. Okay. See suppose if you have one software, okay, it can be installed. Suppose SQL server is there, that you can install it on your system. Okay. The same SQL server service is available on cloud also. Okay.
Sir,
Cloud means
actually, Ashok sir is starting free batch for cloud technologies, sir, SaaS and PaaS.
I know
24
also.
on.
Yeah, yeah. That I have like registered also.
hello.
Sir, tomorrow is the Saturday, so our class will be there on Saturday.
We will update on the
Tomorrow.
group. Okay. Okay.
Which group, sir?
Yeah. Hello.
On which group?
I don't know exactly. See where your data is there. Okay. We will update it. Right.
Sir, are you explaining about like server and cloud, like little bit? You
See,
stop
that's
me.
why I'm telling you. See, the cloud means, okay, if you say, for example, the cloud is like a collection of services. Remember that. For example, it is like a collection of services. Suppose I need a SQL server. So if you can install the SQL server locally. Okay,
Okay.
you can use it. It is a dedicated server for you, right?
Yeah.
Okay, you need to provide all the resources for that SQL server. Okay, from you. Okay, whether you are consuming that SQL server completely or not, but you need to maintain it, right? Wrong?
Yeah.
You need to purchase it, and you need to spend you need to provide all the resources in all aspects for it in a simple way. It may be electricity, or it may be memory, or it may be maintenance, or it may be licenses, or anything. Okay, you are the whole and soul for it. Okay,
Yeah.
suppose if it is a cloud means, simply see, the word cloud is little bit confusing for everyone. Cloud is nothing but simply say, okay, a location where a collection of services are available with hardware and software. Simply say. Now the SQL server is provided by someone, okay, from some location. You are going to access that service, okay, right? So how much you are going to use, you need to pay only for that much. That is important
Okay.
point. So the SQL server is not purchased by you. You no need to maintain the hardware for it. You no need to maintain the you no need to pay any for licenses. Okay, the renewals, okay, and the electricity and security issues, all the things, administration, everything is maintained by that service provider. Okay, that service provider is called cloud. Okay. See what is meant by cloud actually, the general meaning in the real world. Cloud means, okay, see, the cloud which generates rain, right? Wrong? Okay, the cloud which generates rain, right? Wrong? Hello.
Yes. Yes, sir.
Yes, the rain is a collection of drops, right? Wrong? So you are using one drop of it. That's all. There are so many services are there through the cloud. Okay, you can
Yeah.
see, for example, you need a complete system with say for example some 64 GB RAM. Okay, with uh, with some quad core processor or some other. Okay, for one day, only for one day, only
Okay.
for one day. So here, that is mandatory for you, but you can't purchase that high configured system for one day purpose, right? Wrong?
Yeah. Right.
Right? So simply say, from a cloud you can choose your customized server, customized system, okay, with the required RAM, with the required hardware, hard disk, and with required speed and everything, and you can use it for whatever the time you want. Okay, the timeline you want, maybe 1 hour or 2 hours or 3 hours or 10 hours, and pay for it and close it over. That is
Okay.
that is
Like
so that
for shorter time of to use your resources for shorter time, we go for cloud. Otherwise, we go for like our own resources like that.
Yes, exactly. See, while the cloud is nothing but simply say a remote service provider for you, everything
Okay.
over the internet. So here the point is to access all that services, you need at least a thin client. Okay, at least you must have some internet connection with limited thin client, limited system, limited resource based system. It means to access internet and to interact with the interface, okay, you need a mouse and the keyboard and all. That is.